Hello there. We're going to look in this video at the properties of quadrilaterals, and we're going to be using two other areas of maths. We're going to be using our knowledge of, or your knowledge hopefully, of congruent triangles. That once we've proven that three facts are common, that all the other facts about the angles and sides are common, and we'll also be using features about angles formed by parallel lines. Okay, let's look at our first parallelogram. First quadrilateral, sorry. Parallelogram. Now, parallelogram, opposite sides are parallel, and opposite sides are also the same length. I've used arrowheads to indicate that the top side and the bottom side are parallel, and a double arrowheads to show that the left-hand side and the right-hand side are parallel. I've drawn the diagonals in red. Now, to prove something about the property of the diagonals, we're going to be using our knowledge of, as I said, congruent triangles. Let's look at triangle A. That's this one here. And triangle B. That's this one here. I'm going to draw that, highlight that in green. Well, are they congruent? Let's have a look. We need to prove three facts, one of which has to be about sides. Well, immediately we've got that by the nature of it being a parallelogram, this side here and this side here are the same. So that's one thing they have in common. If we look, we've also got two lines that are parallel, which means that this angle here and this angle here must be the same. Alternate angles. But we need to prove three facts. We've got a fact about a side, that's important. We have to have at least one side that's common. We've also got an angle that's common, but we need a third fact. Now I can't say with necessity, or I can't definitely say that the lengths are the same. Can I find out something about the angles? Well, yes I can. I just stop and think, hang on, this angle here and this angle here are opposite each other, and therefore they're the same. So we've got our three facts. This angle here and this angle here are the same because they are alternate angles, and this angle and this angle are the same because they're opposite. So therefore we've proven, therefore we've shown that triangles A and B are congruent. And what does that mean? It means all the other sides that we don't know about at the moment are also the same length. So this length and this length must be the same. And also this length here and this length here must be the same. What does that mean? Well, if we look at this diagonal going from top left to bottom right, it means it's being cut in half. Likewise, the diagonal going from bottom left to top right, which proves this feature about parallelograms. Diagonals cut each other in half or bisect each other. Can we prove they're the same length? No, we can't at this stage. We can't at any stage actually, because we cannot say and prove that the diagonals must be the same length. Let's look at a rectangle, which is a special type of parallelogram. It's parallelogram, opposite sides are parallel and equal length. But it's special because every angle is the same. And having four angles and being a quadrilateral, every angle must be a right angle. What about the diagonals? Well, because it's a species of parallelogram, we know that they cut each other in half. So this length and this length must be the same, and likewise this length and this length are the same. But there's something else we can prove about rectangles and the diagonals. If we look at this triangle here, which I've done in blue, call that triangle A, and this triangle here, which I'm going to highlight in yellow until we come to the shared side, which I'm called triangle B, we can show that triangles A and B are congruent. How? Well, we know this length and this length are the same. So that's fact one. We know this length, which is shared, is the same for triangles A and B. But remember, we need three facts, one of which must be about a side. Here's our third fact. This angle here is 90 degrees, and this angle here in between the two sides we know the length of is the same. Therefore, triangles A and B are congruent, which means that not only, because it's a parallelogram, do diagonals bisect each other, but also that diagonals are the same length. Which means, of course, that this length here and this length here must be the same as this length here and this length here. Right, let's look at our third quadrilateral, the rhombus. Now, a rhombus is a type of parallelogram in which opposite sides are parallel, as with any parallelogram, but also all the sides are the same length. What does that mean about the diagonals? Well, because it's a parallelogram, they cut each other in half. So I know that that length, sorry, do apologise for that. I know that that length and that length are the same, and also this length and this length are the same. They cut each other in half. Can I prove anything else about the parallelograms? Well, let's look at triangles A and B. Now, this feature of a rhombus, that all the sides are the same length, means this other feature can be proven. Triangles A and B. I'm going to try and prove that they are congruent. Right, we need three facts, one of which has to be about a side. Well, this length that they have in common must be the same. It's a rhombus, it's a rhombus, so therefore this length here and this length here are the same. But we also know, because it's a type of parallelogram, that the diagonals bisect each other. So therefore this length here and this length here are the same. So triangles A and B are congruent, which means also all the angles are the same, which means that that angle and that angle there must be the same. Now, just think this through. What does that mean? These two angles, I'll call them angles X and Y, are the same. They lie on a straight line, so they add up to 180, but they're also the same. Therefore, X and Y are the same, and they must be 90 degrees. And the same can be shown for these two angles here. So therefore, we have these features that diagonals bisect each other, as with any parallelogram, and they do so at 90 degrees. Diagonals bisect. At 90 degrees, that is, they are perpendicular. Now, there's one other thing that might be in your mind. Can we show that the diagonals are the same length? Well, no. Look, I know this, if I look at the two triangles, this blue one here and this one here, yeah, they have two lengths in common, but I can't prove that this angle and this angle are the same. In fact, all I know is that they must add up to 180, but I can't prove that they're the same. So therefore I can't prove that the big blue triangle and this green one are congruent, and therefore I can't prove that the diagonals are the same length. But let's look at a fourth quadrilateral. It's a very special type of parallelogram. It's a subspecies really of rhombus, in that, as with all parallelograms, I'm breaking these teeth in for a friend, opposite sides are parallel. Like a rhombus, every side is equal, and like a rectangle, every angle is 90 degrees. Now, what does that mean about the diagonals? Well, as it's a type of a species, that's a good word, of parallelogram, we know that diagonals bisect each other. As it's a species of rectangle, we know the diagonals are the same length. Now, that being the case, if we look at this triangle here and this triangle here, I'll call them triangles A and B, we can see that they are congruent. Let's see why. Well, they have a shared side, so therefore that length's the same for triangles A and B. This length here and this length here are the same. And we know, because the diagonals cut each other in half, it's a type of parallelogram, that this length and this length here are the same. So we've got the three facts we need to prove congruency. And again, that means that, as with a rhombus, these angles here are 90 degrees. And it can be shown that must be the case for these other two here. So the properties of the diagonals of a square are that the diagonals bisect each other. Oh, my handwriting's getting bad, isn't it? Bisect. Diagonals cut each other at 90 degrees. In other words, they are perpendicular. And as with a rectangle, diagonals are equal length. So there's a look at 4 different types of quadrilateral and the features of the diagonals. In fact, we may as well just extend it just to look at one other. We'll look at a kite. Let's look at the diagonals of a kite. Now, a kite has two sides the same, two pairs of sides the same length. This pair and this pair. What about diagonals? Well, it's obvious what they do. They cut each other at 90 degrees, but let's try and prove it. Let's look at the left half and the right half of that isn't very good, is it? The left half of the kite and the right half. Can we prove that they are congruent? Well, of course we can. Here we go. They have this side in common, so that's fact 1. This length and this length are the same, and this length and this length are the same. So triangles A and B are congruent. Therefore, the height of triangle A must be the same as the height of triangle B. I should really use 3 dashes. And, well, can I show any more? How am I going to prove that these meet at right angles? Well, I need to prove something about triangles X and Y. Now, can I prove that they're congruent? Well, yeah. Having established that the heights of triangles A and B are the same, let's look at triangles X and Y. They have, let's get rid of these facts about triangles A and B. Triangles X and Y. They have this length in common, so they have a length the same. That's one fact. These are the same, by definition of it being a kite. And we've just shown, because triangles A and B are the same, that these lengths here are the same. Therefore, it's triangles X and Y, we've shown they have 3 facts in common, are congruent. That means the angles are also the same. So this angle and this corresponding angle are the same. Add up to 180, both the same. Therefore, this angle here and this angle here must be 90 degrees. And this angle here must be 90 degrees. Lies in a straight line, doesn't it, with the one on the top right, and so on. So, what can we say about the diagonals of a kite? They bisect each other. And they bisect at 90 degrees. Okay, so you can either learn all these facts about a kite, a square, a rhombus, a rectangle and a parallelogram. You can learn them by rote, by heart. Or you can remember the rules of proving triangles are congruent and some features of angles formed by parallel lines to prove them from first principles. Anyway, I hope this, which I haven't rehearsed very much, this video has been of some use to you. Okay, thank you very much.